Hello everyone, welcome back to Technish. So today we are discussing the changing landscape of the jobs. So most of you probably know that the things that are going on in the market, that is the mainly the proper engineering jobs like backend engineering, if you are in product engineering, and if you are in full stack development or any other kind of development. So we all know there are two paths, right? That is the product and another one is service. Okay, so product is basically you make a product, you create a product, you try to sell it. Okay, suppose you have created a product that is uh you know it's it's simply an e-commerce website that you will be used to sell some products, right? But in case of service, so this e-commerce product, okay, it suppose it requires some service. Suppose it wants to uh, you know it wants to manage your payroll settings through a service, that is payroll service. So what is payroll service? Is just it's just an HR payroll, where you will manage your salary and the other documents like tax documents. So the product company does not want to manage its own, so it's handed over to the service company based on some certain contracts. Okay, so these two are the models. So here in the service company, a person, a resource gets billed per hour. Okay, but in product there is no such concept like that. Okay, in product what people do is, okay, so they have a project budget. So they decide whether they wants to go ahead with you know so they, if they're funneling capabilities, other capabilities like improvement, performance improvement, or optimized budget or something, so they go for this kind of project budgeting. Suppose they increase it like 5% for a year. Okay, suppose they increase a 5% this year, so the next year suppose they are funneling the more AI funds. So suppose they are having AI funds, they are funneling the AI funds. Now what they will give, now suppose they are going for 25% more. So that's how the product works. So this entirely works like based on the ROI that will generate. So if the product is performing well, they will funnel more. So that's how the product and the service works. So most of the good product companies are Fank, okay, that you already know. There are some other companies as well which are good product companies, and people are well aware of that. For services, there are companies like TCS, Infosys, IBM. So these companies are service providers, so they provide the services. So as you know, we are heading to an area where most of the engineering jobs is going to get challenged. Okay, so suppose we are taking backend engineering, or suppose we are taking full stack engineering. So most of the people that are working on this backend engineering or full stack engineering eventually is gonna, you know, go to a full stack job like backend full stack, or a full stack like to have a knowledge of end to end. Suppose like you are building something, so you should know the front end, you should know the back end, you should know the CI/CD, you should know the cloud, you should know how the integrations work. Okay, you should know the design patterns. Okay, patterns. Okay, you should know these kind of things. Okay, apart from that, you should also know, because this this is a changing landscape that is coming up, so you should know about AI/ML, which is very much important. So I'll discuss that later. So first you have to understand what is an end-to-end means. So if you are trying for a project, if you are building a project, so the first thing what you will need is you so the first thing you will need is a requirements, that what you want to build. So suppose you want to build something, for that you will need a requirement for that, after the requirement is finalized, you should go for a design, right? So this design, you have to be very, critical in thinking. Okay, you have to be very critical in thinking that how are you going to design, so that it improves the, it is a sustainable and scalable. Okay, you have to be good enough to, it has to be sustainable and scalable. Scalable means it should be able to handle, suppose in case of any problem comes. Okay, in that case what will happen is that, suppose you have an instance, you have one instance, and suppose one instance, your one instance is not going to handle this kind of, the kind of load that you're having. Suppose it is not able to handle that much, so in those cases what you do is you scale up to two instances, or suppose, or four instances. Okay, so these things have been already implemented in clouds. So in AWS, you see that there is a concept called auto scaling. So suppose how this auto scaling works. So this auto scaling works basically, you don't need a dedicated four instances to be go on for 24 hours, right? What you need is, suppose in some of the, suppose there are, suppose you are, consuming from a Kafka topic, right? In that Kafka topic is having a batch. Okay, so that Kafka topic is basically, giving you a batch data for a certain period in a day. Okay, in the day, suppose about 4 o'clock, it generates a millions of records. So, and in order to consume it, suppose you take 1 hour, in order for your, uh, uh, in order for your things to get, fully consumed, the messages. So what you do is, instead of having that four instances reserved, you do an auto scaling on for a certain threshold. Okay, so certain threshold you give, if that exceeds, it will allocate four instances to support. So this is called scalability. So your, designs have to be scalable, and your design has to be, it should be, uh, it should not be prone to fail. It should not be. Okay. So if it is prone to fail, suppose you only have one instance. Okay, you have only one instance, and for some exceptions occur, what you do is, so that instances go down. So your uptime is going down, right? Your uptime is going down. So what you do, you have to plan that accordingly, so that you should have multiple instances deployed in multiple, availability zones. Suppose you have an availability zone 1. So whoever is understanding cloud, that is the availability zone, is a zone where you deploy, where you have your servers, or you have your instances. So in availability zone, suppose you have three instances. For availability zone 2, you have three instances. So one instances go down in one availability zone, you still have other instances to support. The other instances can come up. So that is how the scalability works. Okay, so you have your architecture and your, scalability, your design should be scalable. And the front end, how the front end is going to work, the front end has to be scalable as well. Because suppose suppose you have a website. Okay, you have different kind of search options. Okay, so in different kind of search options, so I'll just give you a basic example, right? Suppose your website offers a free search, that is, you are giving some of the search criteria for the free ones, and for the pro users. Okay, for the pro users, you give advanced filters, right? Probably you have seen that in the context of no broker or, magic bricks, where you will be seeing that you have, pro filters there. So in those cases, what you do is, you create a micro front end based. Okay, so if you don't know what is my micro front end based application or design, micro front end is your front ends would be separated for each of the search. I mean, suppose you have a free search and you have a pro search. Okay, so for if your basic search functionality goes down, your pro users will also be affected and your free users will also be affected. So in order to reduce that, you devised the segregate. You segregate the responsibility. That is, in order to do that, you create two micro front end services that will the first one will take of the free search and the other one will take care of the pro user search. In order to you have that, like for this one you have a different infrastructure provision, for this one you have a different infrastructure provision, so that you can make this your apps reliable. Okay. Backend is one of the most important things, that whenever it's it is because it interacts with multiple components, like front end, it checks with the Kafka, it checks with the database. So it checks a lot of things. So your backend has to be good, your backend has to be very lightweight. Your backend has to be very lightweight, your backend has to be less complex. You try to you try to incorporate the solid principles, which is first things. Solid principles, you should know about cap theorems, that is consistency, availability, and uh, that is partition tolerance. Okay, so the cap theorem you should also know whenever you are designing. Now after that, you should also understand the whatever I was telling you, that the scalability, and you should also know the circuit breaker, that gives your website a little space, that okay, this is if your service is breaking, that is the main thing that I've given, like the availability zones and all. For the circuit breaker, what it does is, it has a it has a pattern that will be checked, like if your certain services are broken, you are doing a rate limiter, you're doing a rate limiting based on that. Okay, until and unless I get this certain types of certain amount of responses, I'll be doing rate limiting, and after that, so there is, I'll maybe I'll discuss that in a different video. But for the time being, let's say we do a rate limiting until and unless your website comes up, you are giving, you are defining, okay, this is the rate limit I will provide, and after that I won't provide on top of which. Okay, so backend, and your you have to choose a language which will you know choose language accordingly. Okay, so now the next thing is CI/CD. We all know, that is, you have to know the Docker, you have to know Git, and you have to know Kubernetes, because we will be containerizing the application. After that, it is cloud. So any cloud that you understand, that is AWS, Azure, or GCP, all the clouds you can check. If you find that whatever is convenient for you, you can go for this. Integrations is basically, if you are going for proper monitoring, that monitoring tools, you have to incorporate, you have to integrate, that is, suppose the monitoring tools like Prometheus and Grafana. So these tools will give you good visibility. Okay, and in order to go for other uh, in order to go for other loggings, you should go for Elasticsearch. Okay, Elasticsearch, and you should go for Logstash, that for logging and all. Okay, so the integrations you have to do. For design patterns, you should first understand what is the basic patterns, like factory patterns, singleton patterns. Okay, and the other things like circuit breaker and all. Okay, so these patterns you should probably have an idea. Okay, the the next thing that is coming is, that is the AIML. So you have to understand the AIML very carefully. So what is AI, what is ML, I don't need to explain. Probably you have already know what is what is AI and what is ML. So AI is artificial intelligence, ML is machine learning. So artificial intelligence is a broader part, okay, where it's basically ML is the implementation, where the AI is basically the broader term that people use. So in terms of algorithms, in terms of optimizations, we use machine learning. If it is about data, it is data science. Okay. In AI, it's like uh, AI, you have different kind of models. Okay. So first of all, so there are two kinds of AI models. There are two kinds of AI, that is conservative conservative AI, and another one is generative AI. Okay, so there are two differences between the conversation conservative AI and the generative AI. So first of all, we have to understand that what is AI. So if you have a tool, you know what is Google, right? Earlier we used to do a Google search, but for you have LLM models, right? You have LLM models, that is large language models. In order to do that, suppose you have your website, okay, and is this website is what is doing is it is interacting with multiple components, but in certain cases what it needs is it needs an on the fly and a decision maker that will be that some of it solves some basic things, right? Suppose I'm giving you a proper use case. Okay, a basic example that I'm giving you, that is, you have a website like this. Okay, and this website will tell you you are feeding an image, you're feeding an image. Okay, and it has to it has to tell that what kind of image it is, or if this image contains a model or not. Okay, so this image is having a model or not. So this model is basically, suppose it's a human model. Suppose you have a model like the persons who are inside the picture. Suppose you have a picture of you think about a picture of Brad Pitt. Okay, whether, so model means I'm telling what whether Brad Pitt is present there or not. So in those cases, whenever there is a binary section, whether there can be an output 0 and 1. Okay, like if there is a person present or not, in those cases we do classification. Okay, in classification there are many classification algorithms that you should go for. Okay, you have logistic regression. Okay, and some other stuff I forgot, but yeah. So this is just I'm just giving you a basic idea that how these things are going. So whenever you apply the classification, it will tell you, okay, there is a model there or not. Okay, so based on that you can do some certain compliance work. Okay, if there is a person there or not. So I'm telling you compliance because suppose there is a person, so suppose US government has mandated that, okay, that person, that if there is a person, there should not be the person should be having some kind of age verification. The person should not be a child or something. So there is this kind of compliances can come. Okay, in those cases what you do is, instead your backend service, you have your backend service. Okay, you integrate with Gen AI. So there are very much Gen AI models. There are many Gen AI models like Chat GPT. Okay, so you have gone through the Chat GPT, right? So the Chat GPT works on the model of GPT. So current version is 4 and the latest version is 4.0. Okay, so the generative AI 4.0 you can use, and there are integrating interfaces like Hugging Face. So Hugging Face provides multiple APIs through which, I mean, you have to generate your API key, and you have to integrate it with the GPT-4. So in those cases you will feed the data here, and it will tell you, okay, so if a person is present there or not. Okay, so that is how you can integrate your generative AI. This is just a basic simple concept that I've told you. There are multiple other use cases that are going on, and people are integrating generative AI like hell. Okay, so this is a basic use case that I've given. Okay, so this is like your backend service, and you're integrating with GPT-4o with Hugging Face interfaces. You have an API key created, and after that, you have a certain limit of the request, and if you have that, if you want to upgrade it, you should go for a paid one. So this is a kind of basic AI ML concepts that will be needed because of the changing landscapes. Okay, and we are also not sure that how in the future the overall engineering stack is going to work, but overall the AI and ML knowledge for anywhere in backend engineering or a full stack engineer role you will be required. So apart from this, I missed out that there is the DB knowledge will also be required. Okay, it's basically how you design the DB, how optimization is done, how you do indexes and all based on what kind of data that you're working on. So the DB has to be there. So what kind of DB you use, whether it's a SQL or a NoSQL, or it's a time series database, or whether it's a vector database. So there are vector databases as well that will be requiring for the AI ML sections that we can discuss. There are various vector databases like ChromaDB and all that we can discuss that. Okay, so these are the things. As you can see, it's a very complex thing. You have to know everything from end to end, which is very much required for the modern day job scenarios, that you have to know everything: front end, back end, DB architecture, cloud. You have to know integrations, you have to know design patterns. AIML is must. So you, no matter if you understand AIML well, you will be able to flourish well, because the kind of things that is coming in for the generative AI, you have to understand that how the generative AI works and what kind of, you know, so there is a thing called prompt engineering as well, because you will give some prompt. Okay, in the prompt you write that, think like a chartered accountant. Okay, think like a chartered accountant, and after that you give your query. In query you give some tax query. Okay, and it will think like a chartered accountant. So this is the thing called prompt engineering. So there is a free course of deeplearning.ai. I'll give that in my YouTube description. You can go for that. That's a free course. Okay, you should understand what a prompt engineering is and how to write prompts. Okay, so these prompts can be static, because if you are training your model in a different way, that you want your model to think in a different way, you should have a static queries that will be stored as a prompt, and you can have that in the databases as well. Okay, or you can cache that as well, because these will be static, and after that the query will be dynamic. Okay, so these are the things that will be required for backend engineering for the time perspective that I can see right now. Okay, if I am able to find some new information, I will share that with you. For the time being, keep learning these things. This will build your good engineering background and good job profile. So try to learn end to end things, and try to share as much as possible in your Git, and try to have a good repository ready. So that's it for today. We will discuss the next things in the next videos. Till the time, happy coding. Bye.